Okay, welcome to examples 12 through 15, hopefully. So example 12, we just have a normal factoring problem. It's going to turn out to be pretty cool in the end, but right now we'll just work on it like it's a normal factoring problem. So we look for factors of 9 that add up to 6. Factors of 9 that add up to 6 are 3 and 3, so we could do x plus 3 times x plus 3. But I look at that, I go, oh, awesome, it's x plus 3 times x plus 3. So that means it's x plus 3 squared. And we could have saw that when we began because we know that this is a perfect square, this is a perfect square, and this is twice the square roots of those two. So if we notice that pattern, I have a perfect square here, and I have a perfect square here. So what I'm going to do is I'm going to say, well, this is really, the square root of this is really 2x. The square root of this is really y. So what I can do is I can say that this is 2x, and then I have a minus sign here, so minus y squared. And then if I expanded that out, it would come out to this expression here, the 4x squared, 4x squared minus 4xy plus y squared. So now, on to example 13. So for example 13, we have this binomial, and it doesn't look like I can do too much with it yet, but I do see a GCF in it. So I see that this has a 2 and this has an 8, so I know I can take out a 2 from everything. So let's take out a 2, and they both have x's, so I can make it x, and the lowest power of x is x squared. So I have 2x squared, and then if I take that out, so I'll be left with, if I take a 2 out of 2, I get a 1. If I take an x squared out of x to the 4th, I'm left with x squared. And then if I take a 2 out of 8, I'll be left with a 4. And if I take an x squared out of x squared, I'm left with that. So now I have this binomial right here, and what I notice is this is a square, and this is a subtraction sign. So I have the difference of two squares. So I'm just going to rewrite this as 2x squared times, if you remember, the difference of two squares is x minus 2 times x plus 2. Okay, and then again on B, let's see if I have a similar type of thing. So I have a GCD that I can take out, or a GCF that I can take out, sorry. I have an x in both of them. My lowest power of x is just x. I have a y that I can take out. My lowest power of y is y squared. So if I take that out, over here I'm left with x to the 4th. And over here, I'm left with y to the 4th. So once again, x to the 4th is a perfect square. Y to the 4th is a perfect square. So I can do the difference of two squares. So I have x, y squared times x squared minus y squared times x squared plus y squared. But I'm not done yet, am I? I still have the difference of two squares here. So I could expand this part out to x minus y times x plus y, and then I'll just bring down everything else along with it. X squared plus y squared, x, y squared. And you're going to say, hey, why can't you do that over here? I can't do it over here because this is a sum of two squares. The sum of two squares there isn't a shortcut for that, so I can't do that. I can only do that when it's the difference of two squares. Okay, so now on to example 14. So I have these fractional exponents, and so I don't really know what to do right now. So how about I find a GCF first and take out a GCF? Okay. So they all have 3's, I see. 3, 9, 6. So I'll take out a 3. They all have x. And remember, I always take the lowest power of x out. The lowest power of x here is negative 1/2. So if I take out a negative 1/2, that's really, I'm going to be adding half to this. So I really have x squared minus, if I take a 3 out of 9, I get a 3. Add a half to a half, and that means I have 1 whole. And then I have plus 6 divided by 3 is 2. And then if I add a half to a negative a half, I'm just left with 0, so I don't need to write it. So now I have that. So now, this is something that that looks really comfortable for me to factor, doesn't it? So now, if I want to factor that, I just have to look of factors of 2 that add up to negative 3. So I'm looking for factors of 2 that add up to negative 3, and factors of 2 that add up to negative 3 are negative 2 and negative 1. Those multiply out to positive 2. So I have x minus 2 times x minus 1. Right? Those multiply together to make positive 2 and add up to make negative 3. So I have 3x to the negative 1 half times x minus 2 times x minus 1. Now on to 14b. So now I have one that looks kind of similar to the one before. I have these fractional exponents again. So I know what to do. I'm going to say, well, they both have this 2 plus x. So I'm going to take that out. And my lowest power of 2 plus x is to the negative 2/3. So now, what am I left with if I take x to the negative 2/3, or 2 plus x to the negative 2/3 out of this? I'm just left with x. What am I left with over here? Well, I'm left with, if I take a negative 2/3 of this out, I'm just left with 1/2 of these. So I'm left with 2 plus x. So if I simplify this a little bit, this is 2x plus 2 just by combining my like terms. So let's bring down this 2 plus x to the negative 2/3 times this. And now this is okay, but I see that I have a 2 in both of these terms, so I can take a 2 out if I really want. So I'll be left with 2 times 2 plus x to the negative 2/3 times, I'll be left with x plus 1. Is this much better than this? Not really, but it's a little simpler. Now on to 15. So for 15, I have these 4-term polynomials. So this is something that we haven't done yet. So, but it's very similar to what we did when we had when we had trinomials where the leading coefficient wasn't where the leading coefficient a wasn't 1. I factored by grouping. So I'm just going to take these, I'm just going to chunk them. I'm going to take this part, and I'm going to take that part. So what can I pull out of? What can I pull out of x to the third and x squared? They both have x, right? And the lowest power is to the second power. Here, I'll be left with, if I take an x squared out, I'll be left with 1x left. If I take an x squared out of x squared, I'll just be left with plus 1. What can I pull out of a 4x and a 4? A 4, right? So, over here, if I pull a 4 out of 4x, I'm left with x. If I pull a 4 out of 4, I'm left with 1. So, I'll be left with 4 times x plus 1. And they both have this x plus 1 term, so I can do what I did before and basically reverse distribute. So, I'm left with x squared plus 4 times x plus 1. Okay, and I'm going to want to do that same thing on the next problem. So if you want to pause and try to do it yourself, please do that. If not, watch what I do. So what can I pull out of so I'm going to group again, and what can I pull out of here? The only thing that they both have in common is this x, and the lowest power is to the second power. And then what am I left with? I'm left with 1x and then minus 2. Then I'm going to group this part. So I have a negative 3, so I'll put a minus 3, and then that's all I can pull out, right? And I'm left with x minus 2. Once again, they're both multiplied by the same thing, so I can just simplify that into x squared minus 3 times x minus 2. Okay, and factoring like this is going to become really, really important in the next chapter. So that's why we're focusing so much on it in this unit. So that's it for chapter 1.3. I will see you again in chapter 1.4.